Let's walk through the core principles of Six Sigma Green Belt, explaining each one in depth so you truly master the methodology. The DMAIC framework is the absolute engine of every project. We start by defining the problem and scope, move to measuring the current baseline performance, analyzing the data to uncover root causes, improving the process with targeted solutions, and finally controlling the new process to ensure those gains last forever. Six Sigma is fundamentally a statistical quest for perfection. It defines a quality level of just 3.4 defects per million opportunities. This isn't just a number. It's a commitment to reducing variation so significantly that your processes become incredibly reliable, predictable, and almost entirely defect-free. Project leadership is the human element that makes these tools work. Green belts are the primary drivers of improvement, leading projects in their functional areas, while black belts act as mentors and leaders for larger, more complex, cross-functional organizational challenges. A support diagram is a high-level tool that prevents you from losing your way. By mapping suppliers, inputs, process, outputs, and customers, you get a clear view of where your work starts, where it ends, and who is actually impacted by what you do. The voice of the customer is the heartbeat of your project. It represents the specific requirements and expectations your customers demand, which we translate into critical to quality metrics, measurable standards that tell us exactly when we have achieved true customer satisfaction. Pareto charts are your best tool for setting priorities. By applying the 80-20 rule, they visually demonstrate that a small number of inputs, the vital few, are responsible for the vast majority of your problems, allowing you to focus your energy where it yields the most impact. A fishbone or Ishikawa diagram is the standard for brainstorming. It forces you to look beyond symptoms and explore every possible category like people, methods, machines, and materials to identify the genuine root causes of any performance issue you are facing. Gauge R&R studies are non-negotiable for data integrity. They evaluate your measurement system by testing for repeatability, which is how consistent one person is, and reproducibility, which is how consistent different people are when using the same tool to measure the same thing. Value-added activities are strictly defined as any step that fundamentally changes the form, fit, or function of your product in a way that the customer is actually willing to pay for. Anything else is considered waste and should be aggressively removed. The 8 classic wastes, or downtime, represent everything that slows you down, whether it is overproducing parts, waiting for information, or moving materials unnecessarily. These wastes hide in every process, consuming resources without adding any value to the final output. Standard deviation measures the amount of variation in your data, helping you understand how spread out your process performance really is. Control charts monitor your process stability over time using statistical limits to tell you when a process is running out of control. Remember, specification limits come from the customer, but control limits are calculated directly from the actual data coming out of your process. A project charter is your contract, defining the scope, business case, goals, team members, and the timeline for your improvement project. A histogram is a chart that displays the frequency distribution of continuous data, helping you visualize the shape of your process data. Root cause analysis gets to the bottom of problems, and 5 whys technique helps by asking why repeatedly until the true cause appears. Hypothesis testing uses data to make decisions, and the p-value tells you if your results are statistically significant or just random chance. The null hypothesis assumes nothing has changed, while the alternative hypothesis suggests a real effect exists. Always test for significance. Watch out for errors. A type 1 error is a false positive, claiming a change exists when it does not, and type 2 is a false negative. Correlation measures the strength of the relationship between 2 variables, while regression analysis helps you predict how one variable affects another. Design of experiments is a structured way to test multiple factors at once to see exactly how they influence your process output. Poke-yoke is the art of mistake-proofing a process to make errors impossible, while 5S organizes the workspace for maximum efficiency. Kaizen is the philosophy of continuous improvement, where everyone is involved in making small, incremental changes every single day. A process map visually documents every step of a workflow, helping you identify bottlenecks and opportunities for improvement. The cost of poor quality measures the financial impact of rework, scrap, and lost sales due to defects or bad service. Continuous data is measured on a scale, while discrete data is counted. Always know your data type before choosing a statistical tool. A sample represents a small portion of the entire population, allowing you to infer trends without measuring every single item. Use the mean for the average, the median for the middle point, and the mode for the most common value in your dataset. The range is the spread between your high and low, while variance and standard deviation tell you how much your data fluctuates. A box plot provides a visual summary of your data distribution, including the median, quartiles, and any potential outliers. The central limit theorem proves that as you take more samples, the distribution of their means will form a normal distribution. DPMO stands for defects per million opportunities, and first pass yield tracks the percentage of items completed without any rework. FMEA identifies potential failure modes in a process, and the RPN scores them based on severity, occurrence, and detection. Kanban uses visual signals to manage workflow, and just-in-time ensures you only produce exactly what is needed, when it is needed. Takt time is your production heartbeat based on demand. Cycle time is how long a task takes, and lead time is the total elapsed duration. A control plan is the document that sustains your improvements, detailing how you will monitor the process in the long term. The Gemba is the actual place where the work happens. Go there to observe the process firsthand rather than looking at data alone. Value stream mapping analyzes the flow of materials and information, highlighting where value is created and where waste is hiding. Benchmarking compares your performance against the industry best, while capability analysis tells you if you are meeting your customer specifications. CP measures your process potential, and CPK tells you how well-centered your process is within the customer tolerance limits. Multivariate analysis helps isolate sources of variation, while a scatter plot shows the relationship between two numerical variables. Gauge linearity and stability ensure your measurement tools stay accurate over time and across different ranges of operation. Attribute data is qualitative, like pass or fail, while variable data is quantitative, like wait or time. Control limits are statistical boundaries that determine if a process is stable or experiencing special cause variation. A balanced scorecard aligns your daily activities with the high-level strategy and vision of the organization. Six Sigma certification verifies your skills, while affinity diagrams, matrix diagrams, and check sheets help organize data and ideas. A p-value under 0.05 is the benchmark for significance, while OEE tracks your true equipment productivity. Principles like total quality management, Jidoka, SMED, and Haijunka help you drive automation, reduce setups, and level production. Your project sponsor provides the resources you need, while run charts, sampling, and correlation help you manage and understand results. Six Sigma's ultimate benefit is increased profitability, higher customer satisfaction, and a much more efficient business.